hello everybody. Welcome to our very first hackathon session in 2021, and thank you for joining. So, hey, let's start with a short introduction.
Daniel Katz, I am part of the Helidon team in Oracle for more than a year now, and I would like to show you the reactive messaging in Helidon with Oracle Advanced Queues. So like I already said, I want to show you the Helidon messaging with Oracle's advanced queuing over JMS. We have special connector for our reactive messaging, so we will see few boring slides at first, and then we will dive into the demo. You can reach me anywhere you want. I have always the same handle on Twitter and GitHub and Medium. There are some useful articles on Medium, so take a look there. And how it's going to be, what I want to show you, it's first we will get a really small intro into the Oracle Advanced Queuing. It's we will only scratch the surface because otherwise it would be a really long talk. Then we will do a little intro into microprofile messaging, so we know what we are actually using in the Helidon. Then we will provision on Oracle database in Oracle Cloud for free. Then we will set up some example advanced queues so we can connect with our quick start example to it. And then we will start with the project itself. We will tweak the simple quick start project to use Oracle AQ connector for reactive messaging, see few things around the reactive messaging, and then we will add simple UI with server sent events so we can see the asynchronous messaging visually. And I hope it won't be boring. So let's start with the introduction to the Oracle Advanced Queuing in the Oracle database. Well, it's really simple. It's a full-blown messaging built in the Oracle database. It's in all the versions of Oracle database. It's even in the Express edition, so you can use it anywhere. It has various APIs you can use. We will be using JMS and PLSQL in the demo, but there is ODP for .NET, and basically everywhere when you can use the database driver, you can use the queuing. Basically it's relational data in some database tables, so all the benefits you are used to when you are using Oracle database, like transactions and high availability and those things apply to the messaging also. So it's really simple to use. And if you think about what would be the use case to use the messaging in the database, first thing you can come with, if someone of you have used the Debezium with Kafka for waiting for some events, for listening for some events in the database, and you basically need some the Debezium itself. You need to install Kafka for that. A lot of heavy stuff actually to do to listen for some events in the database. But if you have messaging in the database itself, you don't need anything like that. You can just enqueue the messages from the trigger, for example. We will take a look at some example and try it in the demo. You can transform the messages with SQL functions and do the rule-based routing and much more. You can discover all the tutorials and documentation on the official website. There is a sub-starter page here, so if you want to continue there, we will take a look at the things during the demo. So I don't want to talk you to that with this promoting. This is the example of using the trigger for enqueuing the message. It's really simple one. We have a simple table with 2 columns, and when you insert something, the trigger will enqueue the message with JMS property. That's the new ID from the insert, and the text value is actually the val column from the table. So this is how you can enqueue the messages from the trigger. We will try it out in a few moments. But first, we need to do intro to the microprofile reactive messaging. Microprofile reactive messaging is a specification which standardized the way how to work with messaging in the microservices world. It's really similar to the message-driven beans, if you remember those, or in Spring, if you have some method just annotated that you want to receive some message, and you get that message, that function invoked every time the message comes. It's really similar, apart that it's reactive. That means that you can regulate with the back pressure, you can regulate the flow of the data so doesn't get drowned with too much messages. You have built-in acknowledge abstraction mechanism that's for that you can acknowledge with JMS API. If you have such connector under it, you can commit offset in Kafka with the same acknowledge mechanism, or you can commit the Oracle database, like it's in this case. As it is reactive, it has reactive API. It provides the reactive API, so you can connect it to any reactive API you come across. It's really easy to work with asynchronous APIs. And it has really nice API for creating reactive connectors, so you can create even your own connector and use it in the messaging really easily. So I will move to some examples. This is the simplest possible method for receiving messages. It doesn't look reactive, but it is. It's actually for each terminal operator from reactive streams. So there are some restrictions you have to be aware of, like you shouldn't be blocking the body of this method, because it's actually reactive operator and it shouldn't be blocked as its spec says. And that's because the publisher can be some, I don't know, event loop with a single thread only. And if you will block it, you will just cause a deadlock for the whole reactive stream. So that can happen. It doesn't have to. Most of our connectors would survive some kind of delaying or blocking, but it would be destructive eventually. So we will take a look in the demo how to do the lengthy stuff asynchronously with when consuming the messages. We will get there. We can produce the messages. The producing messages is actually registering the publishers to messaging channels. You can see there is a name of the channel. That's just a name you choose for your channel. Channel is reactive stream, which has one publisher and one subscriber. Those are always only two, because messaging uses a single subscriber approach. You can see here this API, the reactive streams, it's actually another spec from MicroProfile. It's MicroProfile reactive operators, which tries to abstract the reactive operators you are used to in the RX Java or Reactor, like flat map or map. So we have an abstraction layer here. And if you switch to another implementation, it shouldn't break your code. So if you really use only the reactive messaging and reactive operators from the spec, you should be able to migrate to Quarkus or to Payara or OpenLiberty or to Helidon, back to Helidon without any implementation cost. Here, this is the example of using different implementation of reactive operators. This one is using the newer publisher API, which is in Java from JDK 9. It's a Flow publisher, and we need adapter for that, because the reactive messaging is made to work on older Javas like JDK9, JDK8. So they are using the old Reactive Streams API, but it provides the adapters so you can adapt to any reactive implementation you want. So this is how we produce things with the reactive publishers here. As you can see, there are only 4 messages here being produced. Then the stream is completed and the channel is closed. This is the example of using third-party reactive implementations like RxJava or Reactor. Those two are using the older Reactive Streams API, so you can connect it directly like that. So this will again produce 5 messages with payload, with string payload, and then complete. And now comes the question everyone has: how do you publish a message from the imperative code? And that's something which is kind of missing in the microprofile reactive messaging spec number 1 or version 1. And there will be a special tool for that in the next version of this spec. It's already there. It's just not the spec hasn't been released yet. But when it comes, there will be special emitter there. It's not there yet, so we have to do a little trick here. We will use in the demo the submission publisher for Java concurrent flow, Java concurrent package, which is a publisher which implements the new flow publisher interface. And it's able to publish just by calling the submit method. It has built-in buffer. It can do even multiple subscribers. And this is the way how you can actually submit some messages from the imperative code. So from your REST endpoint or something like that, if the message comes, you can just send it through. The submit method returns the integer. That's actually the luck number. It's this. It's basically how much messages are in the internal buffer of the submission publisher. Because if there is some back pressure from the subscriber, it's possible that you will get your buffer overflown. So in production, it's always better to keep it in mind how much you've got, how big is your lag number in here. You can also provide to the constructor the size of the buffer and executor service, which you really should in production. So because internally, if there is more than one subscription, it will use fork join pool, which doesn't have to be what you want all the time. The specification is written really nicely. So if you want to know more, there's a lot of more features. It would be really long here to use the acknowledgement strategies and those things. So you can take a look in the specification itself. It's really nicely, it's really readable. Also, you can check out the article about reactive messaging in Helidon. It's the older one on Medium in our Helidon. It's called Channel on Medium or something like that. So, and now we can get to the demo. We will provision the Oracle database and send some messages. That's what we want to do. Before we start, there is a link to the demo project on GitHub. So if you lose something, you can take a look there. I will try to send it to the chat somewhere, somehow. If yeah, to everyone. So I hope I send it to everyone. Now we can get to, no, not questions yet. Now we can get to the demo. So the first thing we will do, we'll provision the database. So I will connect, I will sign in to my Oracle Cloud account. It's the free account. It's been a free trial, but it's expired already. So you can see there's a few things you can do in the Oracle Cloud for free. like really free. It didn't charge me anything yet. So my personal debit card. The great things are not possible to use in the free tier, but cleverly hidden, there is autonomous transaction processing, which is a complicated name for Oracle database. And we have 2 Oracle databases for free. So we will create a new one. We will choose a name. So it will be Hackathon AQ. Database name will be the same, so it's easily rememberable. It's optimized for transaction processing. We will use shared infrastructure because for free we don't get the dedicated one. It's always free. We can choose the version. We will choose the latest one, and we will select the password for our admin user. So I will choose something really unsecure, like Hackathon 1234. Don't tell anyone. Hackathon 1234. Yeah, it needs to be. We need to allow secure access for everywhere because we will be using the web-based SQL developer. It's the easiest way, and the license is included. So create a database. Now it takes like, I don't know, 3 minutes, maybe 4 of provisioning. So now we can set up our demo project. So we can see what's happening here. So I will use Helidon CLI for initializing the project. We will do the MP flavor. It's microprofile. Bare minimal because we need only a REST endpoint and nothing else. And everything else will be left at default. We won't use the development loop now. So we have the project. I will start idea, bare MP. Yeah, thanks idea. What's wrong? Yeah, this is the problem. I have already started it. So we will open the project. It needs to index all the files we have here. It's probably have too small. So I will switch to presentation mode. I hope you see it. And yeah, we have here only the REST endpoint. REST endpoint returns some hello world message in JSON. We won't need the hello world message. We don't need this because it's not true anymore. We don't need this. And we can reuse that in one of the examples later. So send, why not? Yeah, we will also use the YAML configuration. So I will remove the properties file because it will be more readable in YAML. It will be a really short YAML, don't worry. Application YAML. Like that. I've got few shortcuts, so I don't spend all time typing. It's just there is this weird bug in idea, so I will hide some. Yeah, this is the template for the configuration I have prepared, and this is for the static content. When we will add the UI, I will just leave it here, so we don't need to add it later. First thing we need to set up is the alias for the data source. This is the configuration for the data source. This is the configuration for the messaging itself. So we will choose the alias like Hackathon. It's Hackathon DS. And we will reference it from the configuration of Helidon AQ connector. So it knows how to connect all the channels. The configuration for every channel is always merged with the connector it's referenced to. So this data source will be used for both channels here. And we don't know queue name yet. We know that the user will be Frank when we create it. And we will choose him a secure password like hackathon1234 later. And now we will check out if the database is provisioned, and is provisioned already. So we need to download the wallet with the secrets only for the instance. We will download it. We have to choose the password for the wallet. So I will choose again hackathon1234. It's easily rememberable. Hackathon. I don't want to make mistake here. Download. Now we have the wallet. That's great. So we will unzip it. Download, and it will be wallet something, wallet hackathon zip. And we will use the name of the database as the folder name, so it's easy to configure. It's hackathon AQ, is it right? It's AQ, like that. So now we have the wallet. Uncompressed. It has all the things we need, and we just need to use the path when setting up the TNS admin path, like that. And yeah, I didn't see it. Yeah, and because we have same folder name like the DB name, we can directly use it here. So we have the configuration. We don't have the queue name yet, so we will create the queues. We will go for the service console. Log in as admin with hackathon1234 password. We are there. We will go for development, SQL developer web, which is convenient way how to do it fast when it loads. It's loading. I'm using data center in Frankfurt, so it's only a few hundred kilometers from Prague where I am. It should be fast. Hackathon1234 again. We will sign in as admin. And because I don't remember all the stuff I need to create now, I will take a look in this article about Helidon messaging with Oracle AQ, which is again on Medium under the Helidon. And there is everything explained, even with the local run database. And there are also the scripts we will use now for creating the Frank, our user. Yeah, it's here. So I will just copy it. No, like that. You can see we are creating Frank. We will give him different password, the more secure hackathon1234 password. He will able to connect. He will able to use advanced queues, administer them, and he will able to connect over the REST API, which is needed for this web-based SQL developer. So we are creating Frank, and Frank is created. Now we have to, and I need to get rid of this. Yeah. Now we have to sign out and sign in back as Frank. Frank. And the password is hack. No, one more time. Hackathon1234. SQL, we want to execute queries and scripts. Yeah, that's it. And we will go further in the article, and there is a script for creating the queues, which is faster than writing it. And you can see we are creating more than one queue here. We will use only the first one. I will hide this queue name in the clipboard. And in the procedure, we are creating the queue table. Then we are creating a queue and giving it the queue table name. And then we are starting the queue. It's simple as that. So creating the queues. Finished successfully. I will write down the queue name now, so I don't forget it. Yep. And for later, because I have promised I will show you how to enqueue the messages with the trigger, I have here this is the demo GitHub repo, and I have here the script for creating the trigger and the table. So we will create our table test in schema Frank. It has 2 columns, and it's enqueue every time there is insert into the table. So run it. Yeah, the trigger is there. Everything is prepared, so we can get back to idea. What we are missing here are the channels name. We are preparing 2 channels right now, the outgoing channel, which will be the channel through which we will be sending stuff to the database queue. And so we will call it toAQ. You can choose whatever name you want, but so it's easily rememberable. From AQ, because this is the channel through which we will receive messages. And we have all the configuration we needed. Now we just will comment out this part because we will receive first and then we'll get to the sending stuff. Yeah, and for the messaging, messaging methods needs to be inside the application scoped beans. So we will change the scope, and we will, yeah, we don't have the dependencies, so it wouldn't work nicely. Yeah, there are the dependencies. I will add the dependencies. I have a shortcut for that here. You can see I have added 3 dependencies. First one is for the messaging core in Helidon itself. The second one is the AQ connector for Helidon messaging. And the third one is Helidon integration for Oracle Universal Connection Pool data source, which is really nice because of that we can configure the data source like this really easily. Now we will tell IDEA how to refresh the stuff, and we can start incoming. I saw it. Yeah. Incoming, we will give it the name of the channel. So it will be from AQ. Receive. We will receive directly the payload. I will show later how you can get the metadata from the wrapper, and we will just print it out like that. Received payload, and this is it. This is all we need. I didn't forget anything, I hope. Yeah. So this is all you need. The consuming method. And to run it easily from IDEA, I will create a main method. You can actually start both flavors of Helidon from main method. You don't have to, but you can. Yes, and we will server create start like that. And because we are connecting only to one instance and we want to be fast, I will just disable the high availability feature from the UCP. So the simple fan will be disabled. It would work anyway, but it will be a little slower, and we want to be fast, right? And that's all, I think. Just run it. It's starting. Now it's connecting to Frankfurt. And it's connected. So we will send enqueue some message manually over with PLSQL. We have a convenient script right here in the article again. Yeah. And you can see it's really simple. We will enqueue the JMS text message with text hello PLSQL world MicroStream. And with the current datetime, just like that. And it's enqueued, so we can get back here. We can see that behind the corner, we have received the message from Frankfurt. I will send you more. So you can see it's not mocked up. Yeah, and we are receiving the messages. So now we can consume the messages. This is the easier way how to use it, but we want to also be able to send something. So I will add outgoing method. Outgoing. The channel name will be toAQ this time because we are sending to advanced queue. And we will provide the publisher builder. So it's shorter string publisher builder. It's the microprofile reactive streams operators spec abstraction. So you can create a part of the reactive streams in advanced. It's called stages, and it's really similar approach like you have in Akka, I think, if anyone used that. And we will register publisher because that's what we are doing. Yeah, and reactive streams of hi fellow hackers. So now we will send the 3 messages and complete the reactive stream. And we need to uncomment the part we have commented out. And that's all. Should work. Just like that. It's connecting. It's connected, and we have received the messages. It went to the database in Frankfurt and back here in Prague. All 3 messages are here. So hi, fellow hackers. And now we can try to enqueue some messages from the iterative code from the REST endpoint. We can use this get we have over here. I know it's we shouldn't use get, but just for the demo. But we don't have anything to send, so I will create a path param msg path param msg. So string msg, and we need the submission publisher we have been talking about before. So submission publisher with payload directly. It will be called emitter because this is how it will be called in the next version of the spec. And it will be injectable and nice, and it will work out of the box, and you won't have to be doing this. Submission publisher, you can see, you can set up the executor service, buffer capacity, and other stuff here. When we call the REST endpoint, we will submit the message. And here is the lag number, as you can see, estimated maximum lag among the subscribers. So it's all done. No, it's not. We haven't registered the correct publisher. We should be able to do just this, but we can't because the submission publisher, you can see it implements the Java util concurrent flow publisher, but the reactive messaging expects the reactive streams publisher, which are essentially exactly the same thing. We just need the adapter. So we will use it. Yeah, reactive streams, flow adapters to publisher, like that. And that's all. Yes, yes, it is. So we will run it again. And we will need Carl for that. So Carl localhost, it's 7001. Great. And the message will be, hello, MicroStream, like that. It's been sent and it arrived back. This is the message we have sent from the rest endpoint. So now we know how to send the stuff. We know how to receive the stuff. There is a thing about the metadata. We have been using only the payload until now. So you can also let the messaging to inject either the microprofile message wrapper or its extension, which is for AQ connector is AQ message, like that. It's not payload anymore. And MSG just get payload. You can see that you have all the JMS properties available, the original JMS message. You can get the JMS connection, you can get the database connection, which can be a little tricky, but you can use it. Just be careful because we are using the acknowledgement for committing with AQ connectors. So I will little expand that. We will try to use the database connection here, but it can be lengthy, right? So we can't do it in the reactive operator. So we will use the asynchronous action for that. And this asynchronous action, when it ends, it has to inform the reactive messaging that the reactive pipeline that it's finished. So it can send other messages serially to keep order of things. So we will return completion stage. Void, doesn't have to be anything in it. And we will return completable future, run async. Again, you should use executor service here, but this is demo. So this is where we will be doing the long running stuff. Same as previous, okay. But instead of this, we will get just get the schema from the connection, and we will consider it as a lengthy action. Okay, that's a checked exception, but it's something database-ish to do. Yeah, will be done asynchronously, and when it's done, it will inform through the completion stage it's finished. So this should just work, but if we will do something with the database here, we want to know when the message is acknowledged, when it's actually committed. So we will switch from the automatic acknowledgement to the, you can, there are implicit acknowledgement strategies for different method signatures, but we will use manual here. And when it's done, then compose it. When it's done, we will acknowledge the message. So now we are not only waiting for our asynchronous action, we are also waiting for the acknowledgement to finish, the commit to be done, and then the reactive stream will, the reactive pipeline will know it can send another item through the pipeline. So we have everything finished for this, and it should just work. It started, it's connecting. It's connected. So we will use our REST endpoint. We have sent the message, we have received it, and you can see there is a schema name here. So we have the database-ish stuff asynchronously, and everything works as expected. We will make it simple again, because now it's time for the UI. I will remove the asynchronous stuff. Yeah, white. Yeah, we can leave it with the wrapper. We don't want to use this anymore. Maybe we can get some JMS properties later. And yeah, we will remove it anyway. So we don't need this now because we will use server sent events. We don't need any nodes. Why it doesn't contain any? Okay, I know. That's what I want to fix. We will need some dependencies. So I will add dependency for Jersey server sent events implementation. I have SSM. Yeah. So we have a Jersey, and I have another shortcut here. Now we have a post method for sending the messages from the UI, and server sent event endpoint. Did I refresh the main stuff? Yes. We'll import everything. Okay. Import again, import. I'm not sure if we even need this. We will do it as simple as possible for the demo. So we will have server sent events broadcaster, but we will create it when the first client connects. And when we receive stuff, we will check if it's null. If no client is connected yet, it will just print it out. And if it is, we will wrap the message in the outbound event and broadcast it over to all SSA clients connected. So, am I missing something? We have the emitter. There's a message. This is the payload, of course. Get payload here. Like that. So we are receiving, broadcasting, listening, submitting, registering the publisher. And that's all we need. Like that. The dependency is there. And we don't have the UI itself. Okay. So I will just go for the, yeah, Hackathon. And I have it hidden here, so we don't have to code it manually. So voila, we have UI. It's really simple stuff. There is index HTML with some JavaScript and a few images and styles. What it does, it's only it will give us the input for sending the messages, and it will listen for the server sent events in here. It will invoke this function when the message arrives. It will fly the Helidon, the Helidon bird. It will show the box with the message, and then it will clean the queue after some time. So there are some templates for sending messages. That's all, nothing really complicated. So we will run it again. And I didn't forget anything. Did I? I did. What's wrong? Acknowledgement. Yeah. We have changed the signature, but we didn't remove the acknowledgement. It's not allowed for this type of signature. And now it's going to work. Started, it's connecting. It's connected. We can start the UI and it's blue. We can send a message. So, hello, MicroStream Hackathon. Yeah, we don't need the capital here. Send a message. And it came back from the Frankfurt, and we have the message here. So we can see flying Frank again and again. Messages are flowing through our queue. We can also send something manually, so we can see how it's coming. Yeah, I can queue more. Yes, it's coming. Some network issue. Okay, a lot of messages because, yeah. And now it's time to try the trigger for insert. So I will insert into the table test into, not into. Yes. ID and val values. And ID will be 1. And it will be hi hackers. So we will insert one row and we will get the message, hi hackers. So this is how we can use our database table as the event source without using Kafka and any other heavy stuff. We have just the Oracle database here. So I hope I have shown everything we are working on the other connectors. We already have the connector for Kafka. We have a connector for JMS itself. So you can connect to, I don't know, WebLogic message broker to Kafka broker. You can send the messages back and forward. You can filter them and process them asynchronously, reactively. So you are welcome to try.
So you can find all the videos on our YouTube channel. So subscribe to the channel. Yeah, thank you, Daniel, again for your time and for your presentation. Thank you everybody for joining. Goodbye.
Thank you. Bye.